Alright guys, so today we're going to do Unit 2, Learning Experience 1, Properties of Water. Before we can talk about water's special properties, we should revisit what a water molecule is. So a water molecule is also known as a molecular compound. It's made of two different elements that are stuck together by a chemical bond. So remember when we were doing our matter unit that a molecule is two or more atoms of the same element or different elements that are bonded together. And a compound has to be two or more different elements. So we know that the chemical formula for water is H2O, and those formulas help us identify what kind of elements make up that molecule. So we know that there are two different elements in this molecule, which makes it a compound. The two elements in this formula that we can identify are hydrogen, which is represented by the chemical symbol H, and oxygen, which is represented by the chemical symbol O. And we can even use this formula to identify how many atoms of each element there are. And the subscript for H is 2, so that tells me there are 2 hydrogen atoms. And there's no subscript for O, so there is only 1 oxygen atom. So these atoms are attracted to each other and they form hydrogen bonds. And when they form these bonds, we have a water molecule. And when they form these bonds, the water molecule is kind of formed specially. The hydrogen atoms kind of stick to one side of the molecule where the oxygen is on its own side. And we like to represent it by saying it looks like a mouse. So the most famous mouse obviously is Mickey Mouse. So our hydrogen atoms can make his ears and the oxygen would be his face. Now, H2O, those hydrogen and oxygen atoms, the reason they are stuck together is because if you remember when we were talking about types of bonds that atoms form, is because there's a difference in charges. Hydrogen atoms are slightly positive in their charge while an oxygen atom is slightly negative, and they actually form a covalent bond where they share those electrons. So because there's slight differences in the side of the water molecule, we call this a polar molecule. So anything that has a positive end and a negative end are said to have polarity. So water is not the only substance that is a polar molecule, but it is an example of a polar molecule. So because water is a polar molecule, it has a lot of special properties because it interacts with different substances and with other water molecules in unique ways. So one example of a property of water is cohesion. So this property of water allows water molecules to stick together. So think of co. Co usually means like two. So think of two water molecules hanging out being best friends. So water sticks to water. This is because the polarity of the water and the hydrogen bonds form to make really strong bonds. And because those bonds are really strong, water is super cohesive. We have an example here with water droplets on a leaf. You'll notice that their one large droplet is sucking up the two smaller droplets, and that's because the water molecules are polar. They are attracted to other water molecules, and they form bonds, and they make an even larger water droplet. An example of a type of property for cohesion is surface tension. So surface tension is how cohesion makes things float. So because water has polarity and we have strong hydrogen bonds and water is now sticking to water, it allows the surface of the water to resist external forces until that tension is broken, so we can break it. We have two examples here. We have one really creepy spider kind of walking on the surface of the water. It's not sinking to the bottom because those polar molecules are kind of making a film or a shield. They're sticking together really tightly, allowing the spider to walk across the top and not sink to the bottom, which I'm sure a lot of you wish it did. The second example we have is a paper clip being gently left on top of the surface of the water, and you'll notice there are water molecules aligned so that the negative and positive sides of the molecules are attracted to each other. When they're attracted, they form those bonds, allowing the paperclip to float on the surface. So think of surface tension for water acting like its shield, so it helps keep the shape of the water because it behaves like an elastic sheet. So this gives our water droplets their roundness because the water is cohesive, it sticks to other water molecules, helping make a surface that keeps the round form. And then it allows things like creepy spiders and paper clips to float on the top of the surface of water. And it also gives bubbles their shape so that they don't pop. Another example of a property of water is adhesion. So, adhesion is the property of water where molecules of different substances are attracted and they stick together. So, think of adhesion like an adhesive. Water is going to stick to other substances, kind of like tape is adhesive, and you can stick tape on a lot of different substances. So, some polar substances can attract water more strongly than other water molecules, and then that water molecule will stick to that substance. So, we have an example here where a gentleman is pouring some water, and that water is sticking to the string and then traveling down and being emptied out into the jar below. And then we also have an example of water droplets sticking to the surface of the leaf and not falling off, and that is adhesion. Capillary action is where we take cohesion and adhesion and they work together. And this is where water is able to move up and through porous substances and move against gravity. So porous means like empty spaces. So because there are these empty spaces, water will start to fill up those empty spaces and move up against gravity. So adhesion is happening when the water sticks to the sides of the surface of the substance and then starts to travel up. Cohesion and surface tension is happening because it helps keep the substance intact. So capillary action occurs when the adhesive properties of the substance has a stronger polarity than the cohesive property of the water molecules being attracted to itself. So this causes the water to stick to the sides of the vessel or the porous material and then move up against gravity. So we have an example of water moving up through the straw. And then we also have an example of water moving up through the roots of a plant, through the stem, and through into the leaves. So both examples have water moving against gravity. Another good example would be like if you were to dip the corner of your towel in like the pool and you just left it there, your towel would eventually get wet because the water from the pool will go up through the towel because the towel, while you can't tell, is slightly porous. So it'll go up through your towel and your towel will end up being all wet. Another property of water is specific heat. So the energy needed to heat a substance by a particular amount is called specific heat. Lots of substances have lots of different amounts of energy needed to heat it, so they get heated at different temperatures. Water is special though because of that polarity. They have those really strong bonds, and it takes a lot of energy to heat up the water to separate those bonds. So because it takes a long time, it means that water is going to have a high specific heat capacity, meaning it takes a lot of heat and the temperature is going to be quite high for it to get hot. It also takes water a very long time to release that heat energy once it's stored up. So this can play a really important role in storing and releasing heat, which affects living matter and animals and people and the weather and the climate. So for example, we have this cute little goldfish and it says I love specific heat capacity of water, and that could be because the water takes a long time to heat up, so it's not going to get too hot, while the land might be really, really hot, like the sand gets really hot in the ocean, but the ocean itself might not be boiling, even though your feet are burning on the land. So thankfully for the fish, because of that, they're not going to boil up and die. But also, when it starts to cool off in the winter, the land, it'll lose that heat really fast. So you'll notice the land is actually warmer than the water. So it also helps regulate the temperature in the water so things that live in the water don't die. Another property of water is water being a solvent. So liquids that dissolve other substances are called solvents. And because water is a polar molecule, it dissolves a large number of different substances, and it's often called a universal solvent because of that. So water's ability to dissolve substances is really important for living things because it transports all those dissolved substances through the organisms, and lots of chemical reactions depend on those substances being able to be dissolved in water. So we have an example here. We had put solid salt particles in this glass of water, and some person stirs that glass, and you notice the solid particles start to swirl around and eventually the water becomes a murky salt solution. So on the molecular level, the image above this cup, you will see there is like a cube, and that cube represents the salt particle. And you notice that the little water molecules are now like interacting with that salt-like particle and starting to take it apart because the positive and negative atoms are attracted to the positive and negative sides of the water molecule. So now the water molecule is able to take that apart and help dissolve it. So for your homework, you just need to identify A, B, C, and D, what property of water is being represented in these images. There could be various different answers depending on how you defend it. So whatever property of water you think is occurring or being represented by the image, you need to tell me why by giving me a good example of why. So for example, A is a bubble. What property of water fits a bubble? And give me a brief sentence or two defending why you chose that. And we'll talk about your answers tomorrow after warm-ups.